Hey everybody, let's review chapter 10. I'm going to use the supplementary problems to do that. Be ready to hit your pause button because I'm going to go fast. Ready, set, go. In this problem, we were given 11.5 moles of potassium bromide on the top, moles of potassium bromide on the bottom. So think about what number you put here and what kind of particles you're going to include up at the top. Push pause, try it out. So remember that Avogadro's number, 6.02 times 10 to the 23, is the amount of atoms or molecules, or if it's ionically bonded, formula units in 1 mole of a substance. So that is my ratio. Multiply this out. I hope you used your own calculator for good practice on these because there are some calculator issues that you need to make sure you have worked out before your test. Formula units of kBr. I didn't work out a problem for 2, but when you hit number 2 on your homework for supplementary problems, you're going to start out with something like formula units and you're going to go back to moles. So like working this problem backwards. And if you have those formula units on top, you're going to have formula units on the bottom, which means this entire ratio flips. So be aware of that for number 2 problems. I'm going to move on to 3C though. Go ahead and get that set up. Give it a try. Push pause. And in this problem, we're given 0.155 moles of sulfur on the top, moles of sulfur on the bottom. Go ahead and see if you can set up this ratio. Push pause. So for 3C type problems, when you have moles and you're trying to get to grams, of course, we use our periodic table and find the molar mass for sulfur, set that up for 1 mole, throw that in your calculator, 4.97 grams of sulfur. When you hit up a problem like number 4 in your supplementary problems, you're going to be going from grams to moles. So that's backwards from this problem, which means you'll have grams on top, grams on the bottom, which means this type of fraction will need to be flipped to work out those problems. I'm going to move on to 5C. I'll give you a little hint before you try it out. It will require 2 steps instead of 1, so make sure you include the conversion to moles first. Push pause, try it out. Finishing up, we had grams on top, grams on the bottom, but we can't go right from grams to atoms. We have to go through moles. So in 1 mole, we know there's this many grams from our periodic table. Moles on top, moles on the bottom, and finally we can get to atoms because we know how many atoms are in a mole of silicon. Avogadro's number. Take this number, multiply this number in your calculator, and then divide out this number in your calculator. Some students like to do it this number divided by this number, then multiply by this number. Just make sure that your calculator gives you the right answer because this can be tricky with some calculators. 1.41 times 10 to the 24 atoms of silicon. Use parentheses around denominators when you need to. I like to multiply first, then divide. I just feel like that avoids a lot of mistakes with this kind of stuff. All right, so this was a 2-step problem. For those of you who are visual learners, I'm going to quick show you the mole map, which we'll be digging into a lot more when we get to chapter 11. So our mole map deals with substance A in chapter 10. It'll deal with substance B in chapter 11. So we're not ready for this side of mole map yet, but we'll cover this side today. You can't cross from grams to particles. There's no pathway to do that unless you go through moleville. So remember, grams to moles, then moles to particles. You can't go right from here to here. So 2-step problem for number 5C that we just did. I'm going to move ahead to 9B. So try that one out next. Push pause. So we're given 4.62 moles of magnesium bromide. We are going to have moles of magnesium bromide on the top, moles of magnesium bromide on the bottom. We are trying to get to grams, so calculate the molar mass of magnesium bromide, 1 magnesium, 2 bromides from your periodic table, tally them up. And when we tally those up, we get 184.11 grams. Go ahead and multiply those numbers for your final answer. You'll notice in your textbook, they take a lot more steps to do this type of problem. I think this is sufficient for showing your work on your test. Try 11A next. To find percent composition, you need to know the molar mass of magnesium oxide. I calculated it here. Finish up the problem. And I boxed the final answer here. Don't forget to do the supplementary review problems that I assigned to you on Google Classroom. Study your Quizlet vocab, and that's a wrap.